Welcome to my channel. I'm Zhang Xu. Let's look at the problem 33 in chapter 30. Chapter 30 is about inductance, electromagnetic oscillations, and AC circuits. So there we have LC circuit, right? And for this LC circuit, we can see the L is just fixed, but C can change. C is capacitance. So we can say the capacitor plates are separated by distance x. And tell us this capacitance C can change with x. So there we can write down the function, connect the capacitance with x right in this equation. You can check the previous chapters for capacitance. Now, another thing we know is about this LC circuit frequency. And finally, we need to prove this equation. In this equation, you can see X and A are there, and also we have frequency L, F, and L inductance, right? So it looks like we can start from the frequency of LC circuit. Normally, the frequency of LC circuit, we can write it there. As we know, the angular frequency for the LC circuit can write as 2 pi f equal to square root 1 over LC, right? Now you can input C inside, so the equation look like this one. Now, just reorganize this equation. We can get the function for x just equal to 4 pi squared A epsilon naught F squared L. So proved. The second one tell you when the plate separation is changed by delta x, the frequency changes by delta F. We need to prove delta x this equation, right? So how can we do that? So we can start from this equation we can get. As we can see, if x changes, the frequency f changes, right? Because it's a 4 pi squared constant, epsilon naught constant, A constant, F constant. So you can say this is a function of x with the frequency f, right? Now, if there is a small changes for the x, so small changes for x, we can get the derivation for x, right? So derivation for x is dx equal to 4 pi squared A epsilon naught 2f dfl, right? So we do the derivation at two sides, left side and right hand side. As we know, the derivation is just a small fraction of the x. So dx, we can write it as delta x. df, we can write it as delta f, right? Now you can see, look at the left-hand side for this equation. We need to know delta x divided by x. So very straightforward, we use the delta x divided by x. So x just inputted there. And you can see all this 4 pi squared A epsilon naught F, 1F, and the L cancels, right? So we get the 2 delta F over F. So we proved it there. It's proved. The third part is very easy. Tell you the quantity for the F and the quantity for the delta F. Ask you to find the delta X over X. So very easy, right? We just input F and delta F in this equation. Get the answer there. It's very, very small. Thank you.